All right, welcome future engineers. Today, we are unpacking a seriously crucial toolkit. We're going to explore how to take those huge abstract ethical theories and turn them into concrete, practical design constraints. So think of this explainer as your foundational guide. It's all about building tech that doesn't just work efficiently, but, actually does some real good in the world. Okay, let's dive right into our agenda. We've got 5 main points today. First, ethics, morality, and technology. Second, ethical design tools. Third, Dilemma 1, data privacy. Fourth, Dilemma 2, AI bias. And finally, number 5, the ethical engineer.
Moving right along to Section 1, Ethics, Morality, and Technology.
Now, what's really fascinating here is the distinction between two words we kind of throw around interchangeably all the time. Look at the right side, morality. This represents our deeply ingrained personal and societal beliefs, right? It's the cultural moral fabric that guides us. Honestly, it's a lot like the hardwired hardware of a computer system. But then, on the left side, we have ethics. Ethics is the formal, methodical approach. It's the systematic study of those moral principles. So if morality is the hardware, ethics is absolutely the software. It's the structured frameworks we use to consciously process, evaluate, and navigate those deeply held beliefs.
All right, Section 2, Ethical Design Tools. Let's get into the actual tools.
Our very first tool is virtue ethics. Basically, this framework states that what is moral is what makes us the best person we can possibly be. Now, in the realm of AI and engineering, this translates directly to a focus on character traits. It means you're actively fostering virtues like fairness, integrity, and transparency right into the very design and operation of your systems. It's really about building tech that reflects the good character of the people who created it. Next up, we've got deontology. This framework is all about duty and strict adherence to rules. Under deontology, what's moral is what follows from absolute moral duties, totally regardless of the consequences. For an engineer, this means an unwavering commitment to principles like user privacy and fundamental human rights. You follow the ethical rulebook, period, even if breaking the rules might give you a quick technological shortcut. Then there's utilitarianism. For all the engineers out there, you can literally think of this as a classic optimization problem. Utilitarianism dictates that what is morally right is what generates the absolute best outcome, or maximum happiness, for the largest number of people. So in practice, an ethical AI designed under this framework is going to try to optimize overall societal well-being while actively minimizing harm. You're just trying to maximize that net positive outcome. Tool number 4 is rights-based ethics. This lens asserts that what is moral is that which aligns with everyone's fundamental rights and individual freedoms. In the tech landscape, this approach is completely non-negotiable. It demands the absolute safeguarding of users from discrimination, privacy violations, or really any infringement on their autonomy. It basically acts as an impenetrable protective shield for the end user.
And finally, we have care-based ethics. This framework emphasizes empathy. It argues that what is moral is what promotes healthy relationships and the well-being of interdependent individuals. For a developer, this means putting user safety, emotional well-being, and the strict avoidance of harm at the absolute forefront of any technological priority. It really forces you to ask, hey, how does this technology actually affect the human connections of the people using it?
Which brings us to Section 3, Dilemma 1, Data Privacy. Let's look at a real-world scenario.
So, consider this question. Should we sacrifice user privacy to train a medical AI that could save lives? I want this to act as a mental speed bump for you for a second. Imagine you have access to this massive dataset of highly sensitive personal health information. You didn't get explicit consent to use it, but feeding it into your machine learning algorithm could lead to a huge breakthrough in early cancer detection. It's a real dilemma. What do you actually do?
And this brilliantly illustrates how different ethical tools lead to completely different engineering decisions. On the left, if we apply utilitarianism, this framework might actually justify using that data. Why? Well, because the potential outcome, a life-saving medical AI, optimizes happiness and well-being for the maximum number of people. It outweighs the privacy breach. But then, look at the right side, deontology. A deontological approach strictly forbids unauthorized data collection. No exceptions. It argues that you have an absolute moral duty to respect patient privacy, regardless of the massive societal benefits the AI might bring. It's the exact same problem, but these tools lead you down 2 entirely opposite engineering paths.
However, no matter which theoretical framework you personally lean towards, as professional engineers, there is a baseline we absolutely must meet.
technology development demands essential privacy safeguards. In the real world, this means you must implement robust security measures, obtain informed user consent, and respect individual control over personal data. Strict adherence to data privacy laws isn't just some fun philosophical debate, it is a fundamental, non-negotiable engineering requirement to protect personal information.
All right, let's move on to Section 4. Dilemma 2, AI bias. Now ask yourself, who is responsible when a machine learning algorithm discriminates? This isn't just a hypothetical, by the way. Think about the time a major tech company actually had to scrap an experimental recruiting AI because it taught itself to systematically penalize any resume that included the word women's. True story. When an algorithm is trained on inherently biased societal data, it's going to output biased decisions. So who takes the blame? Is it the AI itself, the dataset, or the engineer who built it? Let's apply those diagnostic tools again to see how they guide our response here. On the left, rights-based ethics takes a really hardline stance. It vetoes the biased algorithm entirely. If a system discriminates, it violates fundamental human freedoms and rights, so it simply cannot be deployed. The core focus is the immediate protection of the user. But on the right, virtue ethics takes a slightly different angle. It focuses inward, on the engineering team itself. It demands that the diverse group of developers cultivate the virtue of fairness, take accountability, and actively redesign the system to mitigate that bias. It puts the responsibility squarely on the creators to fix the underlying unfairness in their own code. So, the crucial takeaway here is that you can't just deploy a system and forget about it. Ethical engineering requires proactive action. Here are the practical steps developers absolutely must take. Step 1. Actively identify biases in your training data before you even train your model. Step 2. Implement transparent decision-making processes. Basically, if your AI makes a decision, a human needs to be able to understand how it got there. And Step 3. Establish clear lines of accountability for the system's consequences. If the AI makes a discriminatory error, there has to be a mechanism in place to address it and take real responsibility.
And that brings us to our final section, Section 5, the ethical engineer.
All right, this is essentially your cheat sheet for translating theory into practice. Notice how the broader ethical considerations we strive for in the industry map directly back to our frameworks. Transparency in tech, making algorithms understandable, is a direct application of virtue ethics, cultivating honesty and integrity. Accountability, taking responsibility for your product's consequences, is firmly grounded in deontology, fulfilling those absolute moral duties. And inclusivity, ensuring tech is accessible and non-discriminatory, is fundamentally rooted in rights-based ethics, protecting everyone's freedoms. So these aren't just trendy industry buzzwords. They're structured methodologies you can and absolutely should apply every single day. Which leaves us with one final, absolutely vital question. What kind of technology are you going to build? Every single line of code you write, every data set you utilize, and every design constraint you set, it's going to shape our societies and our economies. You've got the theoretical knowledge now, and you've got the practical tools. From here, it's totally up to you to apply them. Embrace this profound responsibility. Go out there and build something that doesn't just push the boundaries of innovation, but actively protects, respects, and elevates humanity. Thanks so much for joining me on this explainer, and keep questioning.